Welcome back, everyone. So this is when we start getting into the very technical details of the code and getting values when we want, where we want. So in this demo, we're going to show how not proof of work per se is done, but the process of checking and validation. I guess is the best way to put it. So if you come over here to our main Python, we still have our starting proof of work right here because we do get values from the proof of work down here. But we also get values up here when we validate the sender with the private key for the transaction and everything like that. So what we did. So we go into the validation.py. So this is a validate._LTE. In anything that validates in Python, in PyEVM, it will run through this function. So we're able to grab what it's checking and what the value is. And since nothing changes, I was able to finally trace down where these values came from. And we're about to see that in real time. So we're gonna run our application like always. So come up here, double bump up and hit enter. So we get our normal welcome to PyEVM logger, but since we uncommented part 2, so we get part 2. So like we saw before, part 2, the user's nonce, our Byzantium transaction, that's signed right here. But when we look at the signed transaction, we have V, R, and S. So what are these? So when the sender gets, or it signs the transaction, it uses a private key. The private key gets sent through in a hashing algorithm, and this is the result of it. So why are these values special? So these values are special because it validates the sender itself. But we also see something weird. So in our validation, we were checking things for proof of work because that's what proof of work does. But also any validation runs through that comparator right here, which was interesting because this is the thing we're trying to solve in our proof of work. So it looks like this hash, everything inside the block must be under this value. I've run all these values through. We can see R right here, 3146, ending in 788. We have S right here, 224, and we have 324 to end, 324 to end. And we have 28 and 28. And that's the expected value. Not really sure where that 28 comes in for the checking value. I think it should, no, sorry, my bad. This is the additional leftover. This is part of the padding. So this is part of the padding. This is part of this S and this R is part of the actual result from that hashing algorithm. But then we start proof of work. So when we do proof of work, we come down here, we have our generated mix because header of the block is going to be the parent's header, Genesis, with mix hash. And this is the value we came up with. It did take a little time to come up with this value. We will go into those logs later, but this is just, we're slowly dipping our toes into what these like logger logs mean, so you can decipher them when you want to do this yourself. So this is the value we get. Compared against this value, it is lower. So this is the actual hash that solved this hash. Awesome. Thank you so much for watching. And in the following videos, we're going to get more and more technical in what actually happens behind the scenes when we run this code. But as always, thank you for watching, and I hope you stay tuned. Thanks.